I want to see the.
All right, guys. I'm recording this to see how well it works. All right, so let's look at the fuzzy dice one first, since there seem to be a lot of questions on that. So the secret here is drawing the picture, basically. So I started with this force diagram. Really, we only have the tension that's at an angle here, and we have the weight that's down. Those are the two forces. And this tension can be split up into an x component, which I could say is tension sideways. That's making the fuzzy dice accelerate with the car. And then there's the tension in the vertical, and that is making the dice stay in the air and not fall. So what I know right away is this force has to balance that force. So they don't give you a mass, so let's just make one up and see what happens. So if you make up a mass of 1 kilogram, then the weight down would be 10 newtons. I figured out the acceleration of the car, 20 meters a second divided by 5 seconds, so it's 4 meters per second squared. So, if I times that mass that I made up times the acceleration, 4 times 1, then I end up with just 4 newtons over here, not 40. I had to scratch that out. So that means I now know that the sideways tension is 4 newtons and the vertical tension has to be 10, the same as the weight. So I slide these into a right triangle, and I've got, this is 4 and this is 10. I can just do inverse tangent, get 22 degrees.
I did that a little bit different.
Did you do it with just the accelerations?
Yeah, or just the same.
Right. So if you think about it, since the mass is multiplied by this acceleration to give you the sideways force, but the same mass is multiplied by gravity to give you the upward force, I really could have picked whatever mass I wanted, because I'm multiplying both the mass by both of these two things. So if I would have done 5 kilograms, it would have worked out. 1,000,000 kilograms, it would have worked out. So Veronica's point is you really don't have to do force vectors. You really could just say that the acceleration vectors add up. So this is 10 meters per second squared down. So there must be an acceleration that's the opposite, because it's not accelerating. And then the only acceleration is the sideways one of 4 meters per second squared. You do your vector the same way, you get the same answer. That's what you were saying, right? T?
I know that the car is accelerating on the x-axis, and its acceleration is, 4 meters per second squared or whatever. But since it's pulling the rope, and the tension is in the rope, wouldn't that change the direction of change the tension where the tension is on the rope? Never mind.
Well, let's just say the car speeds up even at a faster rate. And so it then goes to like a double that acceleration. So then the dice is going to hang at a steeper angle. Well, why would it be a steeper angle? You've got the same weight pulling down. You'll need the same weight then, or tension in the vertical. But notice, to get that same tension in the vertical and to have a larger tension in the horizontal that will produce the larger acceleration requires this to have a bigger diagonal or to have a steeper angle. So because the vertical has to stay the same, the only way I can get a bigger sideways is for there to be this to go at a steeper angle. So then the dice hangs farther back, basically. It seems to swing farther that direction. So if you wanted to make a homemade acceleration meter, really you could just take a protractor and hang something from it while you're in your car, put a weight down here, and by how far this seems to swing, the angle here, you could then just do this problem in reverse. Use the angle to figure out what your acceleration is. And a lot of times when they have like physics day, if you live by an amusement park, the closest one to us is Lagoon, which they have every year in May.
Yes.
They used to do these kind of things before we had smartphones and with accelerometers built in, is that you'd make a device like this while you're on the roller coaster. You try to figure out what the acceleration is by the swing of the accelerometer.
I have an accelerometer in my car. It's a basketball.
Oh, is it just
What
sitting
now?
back in it?
If I go around a corner too fast.
A basketball rolls around. I gotcha.
I have like a backpack and a sleeping bag in my truck. There's like a back and forth.
There you
And
go.
if I go over a speed bump too fast, the spare tire stuff in
I have
the
a
trunk
story.
moves.
I have my own